Hi everyone, welcome back to Architecture and Operating Systems module. We are in week 2, and in this week I'm going to discuss binary arithmetic with negative numbers. In the previous week we learned about the binary numbers, how to convert binary to decimal, decimal to binary, and the operations, addition, subtraction, multiplication, and division. If you are not confident about those topics, please go back to last week material and watch the videos. So, negative numbers. Why negative numbers is important? Look guys, if you want to subtract two numbers, like for example 5 minus 2, it's very easy. Actually, maths, we say take away 2 from 5 and the answer is 3. But computer doesn't intend to do it in this way. What it does, it says that, okay, I can write this subtraction and make it as an addition. By how? By adding 5 by the negative 2. So we convert this subtraction to the addition and we get the same answer. 5 plus minus 2 is 3. So why computer does that? Look guys, computer use hardware to do the operation. So in that case, instead of having specific components to do the subtraction, what we do, we use the same components, hardware that we have for addition, we use it for subtraction. So in terms of the efficiency, if we can convert the negative, the subtraction to the addition, actually we make the machine more efficient. So this is the reason that we've got to study negative number to see how we can convert the subtraction to addition. For example, 7 minus 2, we can make it to an addition in this way and get the same answer. So guys, binary addition that we discussed last week is quite important because we are going to use the same concept again. So, negative numbers. What is the first technique that we have for negative numbers? The first one is called Sine Magnitude. Sine magnitude. What is sine magnitude? In sine magnitude, we have byte, which has got 8 bits. In sine magnitude, the leftmost bit is called MSB, most significant bit. So if I tell you guys, this is a sine magnitude number, it means that you've got to look at this bit to understand whether that's positive or negative. Here shows the sign. Here shows the magnitude, the rest. For example, if I tell you, guys, I have 8 bits in sine magnitude, you've got to look at the first bit, MSB. What does MSB tell us? If MSB is 0, we say that's a positive number. If it is 1, we say this is negative number. So, for example, if I have 1 0 0 0 0 0 1 0, what we do, we look at that as a magnitude, we look at that as a sign. So this number is negative, this number is, this magnitude is 2, so this is minus 2. I can use the same concept and say if I have 0 0 0 0 0 0 1 0, here, in sine magnitude technique, this is positive, this is 2, this is plus 2. As you see the difference between these two numbers, here is minus 2 because of this MSB, this is plus 2. If I want to show you 12 and minus 12 in MSB, in sine magnitude, let's start with minus 12. So minus 12, I should have 8-bit. Okay, because that's negative, immediately I make it 1. That shows the negative number in sine magnitude technique. 12, I know that 12, I studied well last week. I know that this is 1, 1. 8 plus 4, 1, 2, 4, 8, 16, and 32, 64. So here, 8 and 4 is 12. So for minus 12, what I've got to do, show the sign 1, and the magnitude, which is here, is 12, and here is minus. For the plus 12, same thing, instead of 1, I make it 0. So, in summary, sine magnitude, MSB, the leftmost bit, if it is 1, we say that's a negative. If it is 0, that's positive. So you've got to only look at the first MSB to find out the sign, the rest to find out the negative. I hope that's clear. But how we do the subtraction? Two techniques that we use. One of them is 1's complement. The other one is 2's complement that I explain after this. What is 1's complement? Look guys, in 1's complement, let me give you an example to actually show you how we do that. If I want to subtract two numbers, for example, 1, 1, 0 minus 0, 0, 1. In 1's complement, again, we've got to make the second number negative and use addition. Look guys, this is essentially our approach. We've got to make the second number negative. To make the second number negative, what we do, we flip the bits for the second number. Flip bits. What I mean, if you flip the bits for this one, you get 0 will be 1, 0 will be 1, 1 will be 0. So, first of all, what we've got to do, we've got to flip the bits. So, then, first of all, flip the bits. Second, add the numbers. I told you that we want to convert it to addition. 1, 1, 0. Now I have to add it by 1, 1, 0. As you see, this is the flip version of this one, second number. Add them. 0 plus 0 is 0. 1 plus 1 is 0. Carry 1. 1 plus 1 plus 1 is 1, and we have carry 1. Please pay attention. In 1's complement, if you have carry, you've got to add it again by the number that you got. So 1, 0 is 1, 0, 0. I'm adding these two. And 1 plus 0 is 1. Look, guys, I said that this number, what is this number? 2 plus 4 is 6. What is this number? Is 1. 6 minus 1 is 5. If you go down here, what we got? 4 plus 1 is 5. So what we do in 1's complement, first of all, we've got to flip the bits. Flip the bits. Two, add numbers, because I said we've got to convert it to addition. 3, if you had carry, you've got to add it again. We have 3 steps. Let's, in another example, do that. For example, I want to subtract 12. Do this. 12 minus 5. So, what I've got to do, first of all, binary. I know that 12 is 1, 1, 0, 0. 4 plus 8. 1, 2, 4, 8. 4 plus 8 is 12. What about 5? 5 is 4 and 1. But you've got to have the same number of the bits. We want to subtract them. Yep. How we do that? By 1's complement. In 1's complement, I told you that what you've got to do, you've got to flip the bits. I'll flip the bits for this one. Look, 0 will be 1, 1 will be 0, 0 will be 1, 1 is 0. I flip the bits. This is my second step. To add them now. 0 plus 0 is 0, 0 plus 1, 1, 1 plus 0, 1, 1 plus 1, 0, and I have carry 1. I said that if you have carry, you've got to add this carry again to this number. Addition. Add them. 1 plus 0 is 1, 1 plus 0 is 1, 1 plus 0 is 1, and we have 0 here. So, sorry, here, 12 minus 5 is 7. Let's see whether we got 7 or not. This is 7? Yes, this is 7. 1 plus 2 plus 4 is 7. So as you see, guys, this is the same technique to get the 7. So, the next one. The next one, so again, in summary, ones complement, flip the bits for the second one, add the numbers. If you had carry, add that carry to the second one. But what about twos complement? We have a better approach, which is twos complement. What is twos complement? In twos complement is similar to ones complement, but the difference is when we add that carry or one. Look, guys, for example, I want to do the same operation here. In twos complement, again, the same story. We've got to flip the bits for the second one. Oops, let me scroll down. So we've got to flip the bits. So flip the bits the second one. 1, 1, 0. Look, 1 will be 0, 0 will be 1, 0 will be 1. In twos complement, you've got to add the 1 now. So step 1, flip the bits. Step 2, add 1 to this number. So 1 plus 0, 1, 1 plus 0, 1. Next is add numbers now. We've got to add numbers. 1, 1, 0 plus 1, 1, 1. Add them. 1, 0 is 1. 1, 1 is 0. Carry 1. 1 plus 1 plus 1 is 1. Carry 1. In twos complement, guys, if we have carry, because we've already added that 1, we discard that. 4, discard carry. So again, our approach, what we do, first of all, flip the bits for the second number, add it by 1, add the numbers, discard the carry. Another example. So this is 5. Again, 6 minus 1 is 5. 12 minus 5, same question again. 12 is what? 8, 4, 0, 0. What is 5? 4 and 1. So what we've got to do, flip the bits for the second number. Look, 1 turn to 0, 1, 0, 1, 1, 0, 0. I've got to add 1 now. 1, 0, 1, 1, 0, 1, 0, 1. Then I have to add these two numbers, this one with this one. Add these two numbers. 0 plus 1, 1, 1, 1, 0, carry 1. Discard the carry. What we get? This one. This is 7. Exactly the same number. So, last example that I want to give you is do another example, but in two technique. Oops. So, another example. For example, I want to subtract 18 by 5. Two methods. Here is ones. Here is twos. So what is 18? 18 is 16 and 2. 16, 8, 4, 2, and 1. 1, 2, 4, 8, 16. Guys, you need to be very good in conversion. Binary decimal, decimal 1. What is 5? 5 is 1, 0, 1. So I have to subtract 1, 0, 0, 1, 0, 0, 0, 1, 0. I want to subtract them two things. In ones complement, what we do, we flip the bits. So what it becomes 1, 1, 0, 1, 0. Then add them. 1, 0, 0, 1, 0 plus 1, 1, 0, 1, 0. We've got to add them. 0, 0, 0, 1, 1, 0, carry 1. 1, 0, 0, 1. Carry, we don't have any carry. 1, 0, 1, 1, 1, 1, we have carry. If we have carry, we've got to add it here. 1's complement. 1, 0. Sorry, here is 0. 1, 1 is 1 carry. 0 carry 1. So 1, 0, 1, 1, 0. What is this number? 1 plus 2, 3. 3 plus 8. So 1 plus 4 is 5. 5 plus 8 is 13. That's correct because 18 is 2's complement. In 2's complement, flip the bits. It's 1, 1, 0, 1, 0. Add 1 now. 1, 0, 1, 1, 0, 1, 1. Now add the numbers. 1, 0, 0, 1, 0, 12, plus this number. 1, 1, 0, 1, 1. Add them. When you add them, 1, 0, 1, 0, 1, 1, 0. We've got carry 1, 1, 0, 0, 1. We don't have carry. 1, 0 is 1, 1, 1, 0, carry 1. We discard that. As you see, guys, we got the same ones. So thank you very much. That was the first lecture for week 2 about binary numbers. Thank you.